Hi, I'm Jeff Simon, Director of the Applied Physics Laboratory at the University of Washington. The dramatic melting of Arctic sea ice over the past several summers has generated great interest and concern in the scientific community and among the public. Here, APL-UW polar scientists present their research on the current state of Arctic sea ice. A long-term downward trend in sea ice volume is clear. They also describe how the many observations they gather are used to improve computer simulations of global climate. These simulations help us to assess the impacts of a future state of diminished sea ice cover in the Arctic.
The annual cycle of Arctic sea ice melt and growth is marked each September, when the ice shrinks to its yearly minimum. And each September the question arises, will a new record minimum be set? Axel Schweiger and other polar scientists at the Applied Physics Laboratory of the University of Washington agree. Arctic sea ice volume is undeniably on a downward trend. There is less ice, and what ice there is increasingly vulnerable to dramatic losses in the future.
We've been interested in sea ice volume largely because we know that the sea ice has been shrinking. We also know that it's been thinning.
For decades, APL-UW polar scientists have studied the Arctic sea ice, gathering data from under the ice, on the ice, and over the ice.
Drop.
Basically, we deploy buoys on the Arctic sea ice. And these buoys measure all kinds of things from air pressure, air temperature, ice temperatures, ocean salinities and temperatures. We'll deploy them from ships going up into the Arctic, or throw them out of airplanes. This animation shows where all our buoys are. These red dots are the buoys, the actual positions of the buoys. As I start this animation, you'll see that the buoys drift around the Arctic Ocean, and the ice tends to drift out through the right here into the North Atlantic. One of the things we've learned is that temperatures are definitely important in driving the melt of Arctic sea ice, but what is also important, and also part of global climate change and global warming, is that the changes in wind change where the ice goes around the Arctic Ocean. So one thing we're seeing is that now that we're in this younger, thinner ice regime, this ice moves a lot quicker, it can be blown out of the Arctic a lot quicker. It doesn't have as much mass to survive a summer melt season. More sunlight's absorbed during summer, which makes it harder for ice to grow during the fall.
My main focus is understanding how sunlight penetrates through sea ice. Some of that solar radiation is reflected back to the atmosphere, but some of it penetrates into the ice column where it's absorbed. The light that manages to get all the way through the ice column then is available to warm the mixed layer of the ocean below the sea ice. There's a kind of a $25,000 word known as albedo. It's kind of just a fancy word for reflectivity. This is an ice core. It is very milky, and that's because of the numerous inclusions of seawater. That's what gives sea ice its high albedo, or its brightness. And so these melt ponds turn out to be really important to the thermodynamics of the ice in the summer, and really important to understanding the ice albedo, how much light is reflected from the ice. They're dark, so they knock the albedo way down.
From year to year, over the past 32 years, we've lost about 280 cubic kilometers of sea ice. How much energy does it take to melt that amount of ice? It happens to be just about as much as the U.S. consumes in energy in any one year.
Schweiger is focused on improved computer models of the Arctic climate, the key, he says, to predicting the future.
These predictions about the future help us assess what are the likely impacts on shipping, ecosystems, and other economic activities in the Arctic.
Probably the best known species, or the icon of the Arctic, is the polar bear. We immobilize bears and attach transmitters, and these transmitters allow us to track bears' movements over the ice year-round.
We find that the sea ice extent is decreasing in the region that the polar bears inhabit, and we're finding that the spring breakup of the ice is coming earlier and the fall freeze-up is coming later, so the polar bears have less time that they're able to spend on the ice hunting. Scientists are trying to understand the role of warming temperatures and changing circulation in how they contribute to the ice loss. But we know that it has an effect on polar bears, whatever the cause is.
Experts at APL-UW are dedicated to ongoing research to track, understand, and help predict the dramatic changes in Arctic sea ice and what they tell us about global climate change.
You've heard from several of the extraordinary scientists at the laboratory's Polar Science Center, a group of oceanographers, meteorologists, mathematicians, and biologists studying the ice-covered regions of the Earth. Polar science is just one of many research thrusts at APL-UW. Explore this site to learn more, and I invite you to visit APL on the web.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.